Ladies and gentlemen, welcome to SQL Server Performance Monitoring and Tuning video brought to you by SQLWorkshops.com. In this video, we will talk about SQL 2014 Buffer Pool Extension. Buffer Pool Extension is a mechanism where you can introduce solid-state drives and extend the buffer pool to the solid-state drive. SQL Server will keep only clean pages, that is unmodified pages, in this buffer pool extension. So in case you lose the drive, you do not lose data. It increases the random I/O performance and decreases latency. There is one significant drawback related to buffer pool extension implementation, which makes most of your queries, large queries with MAXDOP 1, really slow. Let's look at some examples. Here is a database I am going to create for this test. It's called test_BPE. Let's create this database from our test tool. The database is created. Now let's look at the database. It has a 16 GB database file and 1 GB log file. And I'm going to increase the memory to 24 GB for this instance of SQL Server. Then I am going to create a 16 GB table. If you look, each row is 2000 bytes. It has integer, column 1 primary key, C2 is integer, but I do not have a index, so I could scan the table by saying C2 equal to something, or I can say C1 between 1 and 4 million, and I can say C2 equal to 10. It will create a range scan. And here we are inserting 8 million rows, so this table will have 16 GB of data. What we are going to do is enable buffer pool extension, but not right away. After the table is created, we will query this table without buffer pool extension. We will write down the execution time of the query, and then we will enable the buffer pool extension, and then we will write down the time of this execution. Here I have a drive L, which is SSD. Let's do some experiment in this drive while this query is running. What I am doing is I'm starting SQL IO tool on drive L to read for 10 seconds with queue length of 8 kilobyte at a time. Let's see what is the throughput of my L drive. So this is a SSD drive, a single SSD drive. Let's give it 10 seconds. Let's see how many IOs it could do. It can do 27 megabytes per second. Now let's increase the buffer size from 8 kilobyte to 512 kilobyte. Let's execute this one. Let's see how many megabyte it can do per second. We have to wait for 10 seconds. I gave 10 seconds. It's able to do 265 megabytes per second. What if I increase the queue length, outstanding IO, to 24, but buffer size it's still 8? Let's execute it. It's same as the first one, but we have a larger outstanding IO. So 24 outstanding IO. Let's look at how many megabytes per second this is able to achieve. 264. Now let's go to the full capacity. That is, I'm increasing the queue length, the buffer size, to 12, and I'm keeping the queue length to 4. This is an SSD drive, a single drive. So let's look at the performance. We have 512 kilobyte read, a random read with outstanding IO of 4. And let's see how many megabytes per second we can read. That is 509 megabytes per second. This is around the capacity of this drive. Now the table is being created. Let's look at the size of the table. The size of the table is, as I said, 16 gigabyte. Now let's reduce the amount of memory to SQL Server. So we have 8 gigabyte to SQL Server. If we want, we can also restart SQL Server. Let's restart SQL Server, and we will do a table scan on this table tab 72. Let's go here. Let's do a table scan. What I'm doing here is I will also set the statistics time and IO on. I'm doing use test_BPE drop clean buffers. It will clear the entire data cache, and then we are going to select from this table where C2 equal to 10. Of course, C2 doesn't have an index, and this will be a table scan. So this table scan from my experience runs for around 30 seconds. What we will do next, after this table scan is complete, we will enable the buffer pool extension. Right now, buffer pool extension is not enabled. After this query completes, we are doing a drop clean buffers. We even restarted the instance, and we are running this query, and this query should complete any second now. Maybe since we restarted, it allocated memory for the first time, it could go up to 40 seconds. But if we rerun the query, it should complete in around 30 seconds. Let's let this query complete, and then we will restart this query to see how long this query takes to complete. The query took 52 seconds to complete. Let's execute the query again. Now let's go back here and let's see how we are going to configure the buffer pool extension. We say buffer pool extension is in the L drive. This is the drive where we made this SQL IO test. With 4 outstanding IOs of 512 kilobyte, it's able to reach 500 megabyte per second. And I am setting the buffer pool extension to 16 gigabyte. So let's see this query complete. It took 31 seconds, as I told you. When we already allocated memory and we drop clean buffers, it's simply reading the data into the cache, and it took around 31 seconds. This is with no buffer pool extension. Now we are going to add buffer pool extension. What I am going to do while after adding the buffer pool extension, we can check how many pages are in the buffer pool extension by executing this query. It says 4 gigabyte is in the buffer pool, that is in buffer pool extension is false, is 0. So 4 gigabyte is in buffer pool, the regular buffer pool, but there is no data in buffer pool extension. I will start this query. It is going to run this query 5 times, 5 iterations, and it's going to say select start from tab 72 where C2 equal to 10, start current. Basically, it's the same query we executed before, but there is no drop clean buffers. There is no drop clean buffers. We executed MAXDOP 0. The only difference is the buffer pool extension has been enabled. Now let's query how many pages are in buffer pool extension. It will take some time because the buffer is large enough. It has to iterate through to see which page is in buffer pool and which page is in buffer pool extension. Let's look at it. It is still running for 42 seconds. The query completed in 31 seconds when we fully cleared the cache and we executed the query. Now we do not clear the cache, we just execute the query, and it is taking quite a long time. And you might think it is inserting data into the buffer pool extension. Okay, so the query completed now in 60 seconds, one iteration is complete. Let's look at how many pages are in the buffer pool extension. 457 megabyte of pages are in buffer pool extension. Let's refresh. We see 1.6 gigabyte of pages are in buffer pool extension. As you can see, it is slowly building up the buffer pool extension. That's also a reason I'm running with 5 iterations. I want to build up the buffer pool extension. In SQL Server, when you scan the table, it does not put the entire table into the buffer pool extension before evicting the table out of the buffer pool. It is not aggressive. It is populating the buffer pool extension less aggressively, so a single table scan will not end up in the buffer pool. So let's refresh now to see how many pages are in the buffer pool or how many megabytes. We see around 3 megabytes of data is in the buffer pool extension and 3.3 gigabyte of data in the regular buffer pool. Let's look at how many iterations have completed. Only 2 iterations have completed, and the execution time seems to decrease a little bit. It's now 54 seconds instead of 60 seconds, the average time. Let's look at how many pages are in the buffer pool extension. It is 3.8, 3.9 gigabytes. So SQL Server is slowly building the buffer pool extension. While it is building the buffer pool extension, let's see how it is reading the data of the buffer pool. So we have our buffer pool configured in the L drive. We have our buffer pool configured in the L drive, and let's look at performance monitor activity of L drive. I look at the bytes per read. As you can see, SQL is reading 8 kilobytes. When SQL Server writes data in the buffer pool and it reads back, it will read 1 page at a time. It will read 1 page at a time from the buffer pool. That's why you see 8 kilobyte reads. Now let's look how many iterations are complete. 3 iterations have completed. Let's look at how many pages are in the buffer pool extension. So there you see around 5.3 gigabyte is in buffer pool extension, and buffer pool extension is slowly getting pages from this table. Of course, we are running only this single table scan, and it's increasing in size. Let's see how many iterations have completed. 4 iterations have completed. It took 50 seconds on an average per iteration. And we can also look at how many pages it has read so far by using this SPU Pro while the query is running. Let's see if the query is completed. Let's look at how many pages are in the buffer pool extension now. There are around 6.2 gigabyte of data in the buffer pool extension. It seems to be 6.2. Maybe the query is complete. All 5 iterations have completed, and we got some data in the buffer pool extension. Now what I am going to do is execute the following query. This query selects from tab 72 where C1 between 1 and 4 million, that is half of the table, and it says C2 equal to 10, so it will be a range scan looking for value C2 equal to 10 with MAXDOP 0. Let's cut and paste this query in our tool, and let's execute for 5 times. Start current. Let's go to our performance monitor and look at the read size. There you see average disk bytes per read is 8 kilobyte. When SQL Server reads from the disk to bring it to the cache, it can do large reads. SQL Server can do up to 512 kilobyte reads, and it can have many IOs outstanding. But when it comes to buffer pool extension, it will issue only 8 kilobyte IOs, and a single thread will not issue more than 1 IO. So if you look at the disk read queue length, it will always be less than 1 for a query which is running serially. And if we look at the read bytes per second, it's around 17 megabyte per second, 18 megabyte per second. This is because it is reading 1 8 kilobyte IO at a time, one after other. Now you see it's around 21, 22 megabyte per second. This is pretty much close to what we saw with our SQL IO tool. Let's look how many iterations have completed. Not a single iteration completed. It is taking 85 seconds. In our original case, when we drop clean buffers and executed the full table scan, it completed fast because SQL could do large IOs. When the table is not fragmented, SQL can do up to 512 kilobyte IOs, and it was doing many IOs in parallel, and it could complete the query faster. Now, with buffer pool extension, it is limited to doing 1 IO at a time. A single thread can do 1 IO at a time, and the read size is 8 kilobyte, and it took 91 seconds for this query to complete. Let's look how much data is in the buffer pool extension. Let's refresh our view. There is 9 gigabyte of data. as and when more and more data goes into the buffer pool, and if you execute the query serially with single thread, it will take longer and longer because we are limited to using one IO at a time and 8 kilobyte IOs. Let's see how many iterations I've completed. Of course, the query takes a long time, and we will give it chance for one more iteration to complete, and then we will go further with a different example. It's taking 166 seconds for 2 executions to complete, and we can look at the average read queue length. It's still 0.8, and read size is 8 kilobyte. Read size, as I told you, will always be 8 kilobyte. Let's look if one more iteration complete. It should be completing by now. It looks the previous iteration took 91 seconds. There is a possibility it takes longer because as when SQL reads data, it stuffs more and more data into the buffer pool extension, and this makes these single threaded queries that are doing large table or range scans slower. Let's look at it now. This query is still executing. Let's do one thing. Let's cancel this query. I don't know how long this is going to take, or give it a second. I will explain you one more thing. What we are going to do here, execute the query with MAXDOP 2. Let's look if this completed. No, it's still not completed. It completed now. On average, it took 113 seconds to complete this query. Let's cancel the query and execute the same query with MAXDOP 2. Let's see how long this takes. When we execute the query with MAXDOP 2, and when we look at the performance monitor, you see the read size hasn't changed. It's still 8 kilobyte, but the read queue length is 1.6 instead of 0.8. Since 2 threads are reading from buffer pool extension, there are 2 outstanding IOs, all 8 kilobyte at a time. This query will be slightly faster. Let's go to the final example. Here I have a query which selects from the entire table with MAXDOP 0. You remember this query executed in 31 seconds when we cleared the data cache and executed. Let's execute with buffer pool extension on. Now buffer pool extension is there and we are reading from this table. So if you go to the performance monitor, you see the queue length now is 22 because 24 threads are working. On an average, it looks like 22 IOs are outstanding. Of course, this query should complete faster. So we have around 219, 179 megabyte per second completed instead of 27, and this query should complete faster. Let's look at how long this query takes. It doesn't take 31 seconds. It takes a little bit longer. It always depends on how much data is in the buffer pool extension. So if you have a lot of data in the buffer pool extension, of course it's doing 8 kilobyte IOs and it takes longer to complete. We have more data in the buffer pool extension, around 11 gigabyte. So the query completed in 57 seconds. If we start the same query with MAXDOP 12, there will be only 12 maximum IOs outstanding. In our case, there are 11 IOs outstanding. Of course, the read is not as high as before, a little bit less. So as and when you decrease the max degree of parallelism, less amount of IOs will be outstanding, and this will have a negative impact on performance. In SQL Server, when a thread is reading data and the data is already in the data cache, that's the buffer pool, it will directly access the data. If the data is in the buffer pool extension, SQL Server does not move the data from buffer pool extension into the buffer pool. In that case, it has to replace useful data out of the buffer pool. Let's say we have a table 16 gigabytes sitting in the data file. Our buffer pool is 8 gigabyte and our buffer pool extension is 16 gigabyte. If we are reading 8 gigabyte and that 8 gigabyte happens to be in the buffer pool extension, SQL will not copy that 8 gigabyte back into the buffer pool because then it has to remove all the useful pages out of the buffer pool. So what it will do is every thread will have 1 kilobyte, one page, that's 8 kilobyte local storage, and it will read directly from the buffer pool into the thread storage. After it processes the data, it will issue a next IO operation. Once that IO completes, it will process the data and it will issue the next IO. So it will do singleton IOs without affecting the quality of the buffer pool. What I would recommend, in case you are using buffer pool extension, avoid large serial range scans. If you have to do large range scans, make sure you have enough amount of worker thread. That is, you are not running with MAXDOP 1 to take advantage of your extended buffer pool extension, the SSD drive. When SQL Server is waiting to read from buffer pool extension, the wait type is EC. Let's look at an example. Here is a SPU Pro command. It looks for IO and wait details. Let's execute SPU Pro. Right now, no active queries are running. Let's start this workload where it is going to do MAXDOP 1 access of this table and buffer pool extension is active. Now let's execute this query and let's see what is the wait type. SQL is reading from the cache before. Now it is reading from the buffer pool extension and the wait type is EC. When SQL Server is waiting to read for the IO to complete from the buffer pool extension, the wait type is EC. If you want to download SPU Pro, you can go to sqldownload.com. There you can click on download and you will see SPU Pro version available for SQL 2014 until SQL 2005 SP4. If you want to download the SQL test tool, you can go to sqltest.org and in the download you will find the link to install. And if you want to know more about us, you can look at the workshops we conduct, the workshop agenda, the schedule, and our consulting offers. We are a consulting company based in Munich. We provide SQL Server performance tuning consulting. Thanks for watching the video. If you are interested in the example scripts, send me an email or join our mailing list. To join our mailing list, click here on subscribe to our newsletter. Bye.